again, statistical exception detection system. It is a methodology to capture anomalies and to detect exceptions statistically, and also to detect the trends. The basic of this is just a statistical process control and some other statistical filtering technique. I've built this, based on this methodology I built a few solutions in different big companies, some banks. Right now, I'm working as a I'm just in consulting, and I'm trying to promote and to implement these approaches for my client. But the beauty of this, actually you could find now the commercial products which has similar features. So it's not an application, it's just a methodology to use these features to do their proactive and very modern way for capacity planning. This particular presentation, as I said, SEDS-Lite means I decided just to disclose, to show everybody how it can be done easily using not expensive tools, expensive vendor commercial products, but just as some absolutely free open source tools. First, I would like to tell you a little bit more about SEDS methodology, and actually, using my blog, this presentation and this paper actually was written based on several postings I published on my technical blog. I will provide the link to this, and there are my cards with their blog URL. You could pick this up. I just published a few posts, and I combined them. It's kind of a declaration. Okay, let's try to create open source tools which use this SEDS methodology. And this presentation is just introduction to this, and maybe encouragement to finally to build this. It's not yet built, but everything is ready to do this, and I will show you how to do it. Open source. Open source tools are started to be used for capacity management, and I'm going to make a little review what's done and actually within a CMG even. And what is available and how it could be used. Just to show the beauty of these open source tools or ability to analyze data, I decided to experiment with a control chart. It's my favorite way to visualize performance data, and so this presentation has links to the postings. And most of them are about control charting using different tools. One of them is R system, and there is a postings, and also there is a presentation, other CMG paper I wrote just about how to build, how to read, how to use control charts, different type of control charts. And I ran a workshop a couple of years ago just to do it. Maybe some of you already know this. One of the ways to build control charts is just Excel, and it's a very good. Everybody knows Excel, so it's very good. Opportunity just to understand how it works. Just use a pivot table and build this control chart. I will show you a bit later. Another way to do this is using some BI, business intelligence reporting tools. One of them I used for this presentation and for this effort. It's a BERT BI reporting tool, which is actually also open source, and you could download it to your laptop and play with this. It's a pretty modern approach to build their data cubes and their control charts, especially these IT control charts, my favorite variation of this chart which I introduced recently. It is actually the data behind their IT control chart as a cubical data. So it naturally could be built using the data cubes. And the BERT, for instance, has this ability, and I will show you how to do this. And where the data is stored, it could be also open source database like MySQL, and I took this particular database and played with BERT and R against this data to build control charts. Different type of control charts. I mentioned IT control charts. It's just their metric itself based. I mean, the control charts against their actual performance metric, but it could be built against their meta metrics, some additional metrics like EV. I introduced this exceptional value meta metric long ago, and that's a very interesting result and could be built, and I will show you an example. And the last part of the sets, it's exception detection. It's not only control charting. First, you need to detect exceptions, just to narrow down the objects you need to worry about, and then for each object you could build some reports like control charts or triangle analysis, etc. But how to capture automatically exceptions? If you have a big number of servers, thousands and thousands of objects. You must have some exceptional criteria to select those who need some attention, some unusuality, or something which really could cause some problems soon. And I have an example here as well how to do this. The simplest way is just to use some query. And I will show you an example of SQL code which could be used for that. Okay, first of all, we need to know what SEDS-Lite is. There is a structure of this. This introduction of this SEDS-Lite introduction was published on my blog, technical blog, and basically there is several parts. Starting with the raw data, and you could see this raw data at the left part of the slide. The data is supposed to be behavior of some object, so it's supposed to be stamped data. I prefer hourly stamped data for some objects. It could be a set of objects. It could be a set of servers or applications or subsystem like CPU or memory, or even some part of the application, for instance, for MQs, it could be some queues. It could be different because it's a statistical approach. The data could be different, or even just a response time or number of hits, their business data, etc. So you need to have this data somewhere in stamped way, just kept. That's strange. It's just raw data. This raw data, I don't like it. This raw data then needs to be ETL'd, needs to be extracted, transformed, and loaded to another database, which is much smaller because it has only most recent data, most recent, let's say, just 7 weeks data, 7 days, 1 week data, and also it should have some parameters some learning parameters. For instance, it could be just based on the baseline, some statistical parameters like upper control limit or low control limit or just averages. That data should be in cubical format. And again, it's supposed to be transformed from raw data. And I will show the example of a script which could do this from raw data to this cubical format. And when we have this SEDS database, then you could analyze it and to capture to detect some anomalies using some filtering criteria. That could be statistical criteria or some even non-statistical empirical kind of rules and some knowledge base like it's showed here. Basically, the system should detect, should provide you their short list of objects it needs to attention, which actually has some most unusual situations. And then for each of these exceptional object, you need to create a control chart to see in details what's going on, and some exceptions could be seen. And then you could drill down using other tools, but it's manageable, become manageable because it's just a manageable low list of objects to analyze. That's basically the concept of SEDS-Lite, and let's see how it could be implemented. I just didn't mention the reporting part of this. Of course, you need to have some reporter. I call it reporter, just to visualize some portal data, of course. Okay, how it could be implemented? Of course, you can use some commercial tools, BI tools, or statistical tools. And in my earlier implementation, I'm SAS programmer. I wrote SAS program, and it's relatively easy to do. But what about open source? Can I use open source for everything, for all parts of this SEDS-Lite? Yeah, I just took a look at what's available. I mean, and actually I found a few interesting presentations which were done within the CMG, and you can see I listed it here. Measure it. The article has a good overview of their open source capacity and performance management tools. It was done in 2004. Several years ago. Just recently, last year, the Adrian Cockroft had another presentation for some regional CMG, and it's actually my slides has a link to this real internet resources you could click and see. Measure it, or the presentation in this local chapter, which lists the capacity planning performance monitoring free tools. It's good, but something is missed. It's my opinion. Maybe I just didn't found it. Correct me if I'm wrong. But what I didn't find in those reviews, I didn't find how just general, not specifically for capacity and performance management tools, but just general open source tools like business intelligence tools could be used. Or some statistical programming system, open source statistical programming system could be used to analyze data. And I'm listing these tools which are not specifically developed for capacity management. But the nature of them, like BERT for instance, it's a reporting tool, BI reporting tool. MySQL, it is just a general database, which the BERT and MySQL could work with the performance data, right? And also statistical programming system, R, for instance, it's become very popular, and CMG has several very good papers and presentation related to how to use R against performance data. So I listed them, and then I decided just to to show you how it could be implemented, how it could be used to implement SEDS-Lite. And you know, it's interesting, in the paper you could see several options, because all parts of the sets, raw database, transformer, ETL, sets database, grapher, detective, and reporter, all of them could be done with different combination of these two. Actually, everything could be written on R, because it's just a programming system, but with some limitation, because yeah, that would be nicer if you keep data in real database like MySQL. And you could do reporting using R. There are a very good way to present the graphics on R graphics. But you know, maybe it's easier to use specialized reporting tools. Specialized not for performance management, just for any reporting. So BERT could be used as well. And I will show you examples, and then you could decide which is easiest. Some methods requires some programming. If you don't like programming, you could use just pick and choose objects from their palette, like BERT does, and so on. Before showing some examples, I'm going to remind you what control chart is. This is an example from one of my papers, which was published a couple of years ago. Because my favorite type of the control charts, it's not a classical one like shown in shown here, because it has a static, relatively static, but constant for some period of time control limits. It's just a classical statistical process control. This is a CPU utilization for 8 hours, for 8 a.m. Each Monday. Why each Monday 8 a.m.? Because I strongly believe that the 8 a.m. Monday should be treated differently than 10 a.m. Sunday. So each hour of the weekday should be treated independently and analyzed independently. Having this, for instance, for 24-hour period of time, you have to have 24 control charts stacked together in that kind of a third dimension, and to build this MISF control chart. This picture shows the relations between the classical control charts with some outlier captured, some exception, and also each hour like this could be presented by histogram, just to see how normal the data are. It could be not normal, so use not deviations, but some non-parametric techniques like percentiles to have these apparent control limits. But stack together all 24 charts, you will see the MISF control chart. Black line is actual data, red line it's in this case it's a mean plus standard deviation. It's calculated based on 6 months history. This about more than 30 weeks. And the green one is average, and the blue is low control limits, the mean minus 3 standard deviations. This is a chart I'm going to use as example for this implementation. Yes?
Would you mind using the screen pointer, because then it shows up on the record and the laser doesn't?
It does not? Okay.
Right.
Okay.
If you don't mind.
Yes, I will. You could see here another link, power of control chart. I made a few workshops in here and national, also on some regional CMG meetings. So you could click and to see it's available, freely available through the internet. Okay, first of all, let's take a look how R could be used for that. The input data is just a comma separated data. Let's imagine it's already prepared. You know, it's already there's control limits already calculated for you. So we just need to visualize and to create a control chart. So just to do this, the very small R program could be written. There is an example. It's published in my blog or in other papers, so you could use it. It's very powerful. I mean, the R system is very powerful for visualizing. The graphical part is very good, and just a few rows and the control charts could be seen like this. Actually, if you are interested, the R system has even some packages, you know, the specialized packages. One of them are just for quality control. Of course, the control chart is there, but this is not for AT performance data. It's just for more broader, for production data like engineering, etc. Because the control charts, it's one of the tool of the Six Sigma or some production control system, quality control, etc. So I prefer building myself, not using this particular package. I actually wrote even some near long time control chart and simulated it using R. I can, at the end of this session, if you have time, I will show you this live video to show how it works. Idea was to capture, to refresh this control chart every hour. If you could afford this, it was a very powerful way to compare the current behavior of your object application with a historical baseline. Every hour, it means the possible unusuality could be captured in a near real-time manner. And I made one implementation of this. But you know, for the big farm of computers and objects, it could be a little bit costly in terms of the performance, because you need to scan all your 2,000 servers and every hour to update this chart, which requires some capacity. So it's another capacity problem could be to build the capacity planning process. But it's very interesting, and I know some commercial products trying to do this as well, just to being seen, for instance, on others to do it in a real-time manner. But they do it differently. They don't do this MISF type grouping. They do just looking at their day or two history and to calculate this statistics, which I don't believe it's very accurate. Let's take a look at another open source tools, which is a BERT. And I'm going to show you how the BERT could be used to build the control charts. Again, there is a link to the blog posting about this. And the actual, but not about this. Actually, this tutorial demo is about how to use BERT. BERT is a freely and pretty popular BI tool, and you could find easily the documentations online or videos from YouTube how to use it. I just installed it on my laptop and played with this. But before that, I had one client who actually implemented their Tivoli portal and ITM data could be analyzed using some built-in out-of-box reports based on BERT. And I tried to use it, honestly. And there are a couple examples. You could see control charts which were built using these out-of-box reports which Tivoli has. But I don't like it because it's a classical statistical process control. It's not MIF. It's MIS, not based on the filtering and grouping, which I like. So I decided to build my own weight, my own favorite control chart using the bird. And especially, I like they're actually not for 24-hour period of time to build the control charts. I like entire week, 168 hours profile, because it gives you a picture about the weekends, how the weekends is doing, and how the work days, and it's not very busy for to see this type of chart. And so I did this again against the same comma-separated data which already prepared, and some the limits are, all limits are already calculated. I just need to visualize it using the bird, and that's easy. It's similar like an Excel. You need to just to pick and choose to assign some metrics to some fields. There is a designer, chart designer you could use. And here is example. And you could see, by the way, exception captured. There's pretty severe exception captured here. But you know, before this very severe exceptions could be seen, it was a kind of a not obvious one. So if you use this, you could be earlier notified. That kind of early warnings could be done by just analyzing this chart. But usually, unfortunately, these proactive exceptions are missed or just ignored by people because they don't want to be worried about if something, about even 60%, 50% security utilization. Nothing. It's unusual, but nothing. They want to, they usually wait until it's a disaster, it's something broken, and they try to fix it and get credit. Oh, I fixed something. It's a cultural thing, and it's hard to build a good process around this type of proactive reporting. But it's a separate discussion. So I used Bird to build this. But as I said, the comma-separated file has already calculated control limits. I'd like to show you how to calculate these limits, how to build this cubical data. First of all, it could be done using spreadsheet. The slide shows example how it could be done. First, you need to you need to little bit modify the raw data. It's not just hourly stamp data, but you need to calculate something. You need to add some calculated fields like week hours. It's supposed to be from 0 to 167, and also you need to calculate weekdays, just to analyze differently Monday and Sunday, like I said. So hours and weekdays needs to be there. And then when it's done, you need to use pivot table. Just a pivot table which could be used to calculate standard deviation as a standard formula for Excel. And then to put together the main concept of this type of control chart, you need to put together the most recent data, last 168 hours, with their baseline statistics. So basically it's two data sets you need to merge somehow or join. So you have to do it with some Excel manipulation. And then when this data is built, you could use a pivot chart. There is in Excel there is a pivot chart which could be used to build the same type of control chart. The pivot tables in Excel, actually it is a way to represent the cubical data. So let's try to do the same but using a bird. We have now raw data. We don't have limits calculated. You could see at the left this raw data, but we need to build their SEDS database, the cubical format, as a preparation to build the control chart. And you know, it's just this picture illustrates that the control chart data for control charts actually is a cubical because it has another dimension. It's a weeks, and this is just illustration of that. Okay, so it's possible to do, and you could see the result, but later I will show you a bit more details how bird report design does it. And here it is details. Again, the first step to tell the tool what is a reference set. Or it's a reference set, it means baseline, based on which we need to do some calculation, control limit calculations. It needs to be done and you could see how it's done with bird, because you could specify this using some expressions, some filtering, just by the data. We could specify using some filtering what time period, what window we could consider at the baseline. It's relatively simple to do. Then we need to do that similar, but for actual data set, not baseline, but just most recent data. But theoretically, you could to do this not for most recent, for any period of time. For instance, if you had test or some in the past some important events you'd like to analyze, you could specify the actual data that period. But most likely, it's supposed to be just last 7 days and 168 hours. And you could do it as well using the same technique in bird, just providing this filtering, providing some expressions against the date and time stamps. When it's done, the next step, as I already mentioned, you need to combine both data. How it could be combined? Merging this data. The usual way is just to join them. And you don't need to write any queries in a bird. You could do it just picking and choose what fields needs to be used to join these two data sets which are already specified. And this is example you could see. It's supposed to be by week hours. Week hours, both data sets, baseline and actual data. Has this week hours field. This needs to be used to join the two data sets. And then there is a special category which is called the data cube and bird. And then you need to tell which one in this two data sets, combined data sets, has a dimensional feature and which one is just factual. So you need to specify it using just again pointing, clicking in their special tool. It's called a special subtool of this tool. It's called Data Cube Builder, and this is example how it's done. When you build this cube, then you need to visualize it. You need to build report. To visualize this, actually, as far as it's a cubicle, you need to have a cut, two-dimensional cut of the cube. So to do this, there is a cross table object. You need to drop it on the report desktop, and then you need to tell this cross table which fields you need to visualize. Some of them you need to even calculate. For instance, this could be standard deviation formula used for that. When it's done, you just need to drop chart object on the reporting desktop and to bind this chart object with this cross table, which is built based on the cubicle model. And when it's done, you just need to run the report and to see the result. The result will be the same like we just saw before when we used pre-prepared data or just our program. I don't know how complex it is. I would prefer to do some programming because I'm a programmer. So I don't really like just picking and choosing some fields and do some assignment, some binding within the tool like Word. Or it could be even commercial tool like, for instance, Cognos. And now I'm using Cognos a lot to do this. But I don't know, there are pros and there are contras. If you're not a programmer, of course, you don't have any other choice. But if you have any programming skills, I would recommend still to use R or just a SQL scripting. So the question is how difficult to write just a SQL script, a SQL script. And just for this purpose, I used another generic open source tool, which is a MySQL database. And this is example. First of all, this example shows how to create their raw data. It could be, in this case, raw data is again the same as a comma-separated file, which could be then uploaded to the some table on a SQL server. It's just a few lines of SQL code. It's not a big deal. This is SQL code, a little bit more. It has a little more lines, but still small. But this particular script calculates the cubical format of data based on the raw data we just created on the previous slide. And you could see in details, but some comments tells you what it is. But basically, there are several similar steps creating a temporary table. One needs to define baseline data or reference set. Another one just to build another temporal table, which is actual data, using the same filtering against the date and hours. And the next step, to aggregate them together using just join, inner join over here. And then the cubical format data is created. Again, it's the same concept. You need to have two data sets to merge and then to be used to create some report. Then the question is how to build a control chart. The database now has a cubical format. How to build a control chart. SQL Server does not have ability to build the charts, so you have to use some other graphical tools or reporting tools to build the control chart. The same bird could be used for that, but now this is example that previously we just used comma-separated file attached to the bird and we got some chart. But this is a bird to use against MySQL data. You need to specify connection string. You need to have a GDBC driver, which is also a free tool you could use. And then you need to provide some connection string to this MySQL database. I have it in my laptop altogether. MySQL, R, Word, and actually everything is on Linux. So everything is open source. Ubuntu. I just provided this connection string, and then I see, after that I could see the structure of tables. Just a simple select could be used in the bird. And again, the same chart object needs to be dropped in their reporting desktop. And you need to provide what is the x value, what is the y value, and then run this report and to get the same control chart. But now it's like more like their production system. You have a database with data. Now we have reporting tool running against this database, and we have some report which could be published on some portal. So it looks like some kind of the application already. One more important thing, I would strongly recommend to use the parameters for the reports. And Bird can generate parametric reports. What type of parameters it could be? For instance, if you have several servers, the server name could be a parameter, and also each server could report about different metrics, CPU, memory, and I/O. That could be another parameter. So, and the Bird easily can be used to generate a parametric reports like this. Bird, we just used Bird to visualize the control charts, which actually was prepared in the MySQL database. But you know, not only Bird could be used, R also could be used to run against the MySQL database. And this is example, and again the code is very short, it's just one page of the code, it's written on the R, but I was kind of lazy. Of course, R could be used to do some very complex statistical analysis. And we saw a lot of examples even in some presentations here. But I was lazy and just decided, okay, we already created, I have already written the SQL script against some tables to build this cubical format. Can I just somehow to run this SQL script, SQL statements with an R? And I found a way to do this because there is a package, it's called RMySQL package, R. R has a lot of packages, one of them just RMySQL, and I use this. So what I need to do only just to call this kind of procedure from this package to provide the SQL statement and run it. And one by one, every SQL statement I already built could be used with an R. And you could see a result. This is the code, and there, and you could see the same result, the same control chart can be used. Could be seen after running this R script. Last thing, I think, almost last topic for this. Not only just a classical control charts against their metrics like CPU utilization can be used, but also I would recommend to use another meta metric which I called exception value. I introduced this way to analyze magnitude of the exception long ago in one of my first CMG paper in 2001. Because it was pretty natural. The exception, exceeding the upper limit could be just a few hours, 1 hour, in a very, very short period of time, and then everything back to the normal. Is it a severe exception or not? It's hard to say. It could be several hours. You could just count how many hours the upper limit was exceeded. Yeah, it's another way to estimate magnitude of the exception. But I decided to do it more mathematically, just to calculate the area between upper control limit, low control limit, and the actual curve. It's kind of integral and could be calculated. And then we could estimate this value, exception value, for the period we care about, like a day or week. And also, it's important, those numbers, red, colored by red, extra value, and colored by blue, colored by blue, has a different sign, positive and negative. And I think it's a good idea to look at the sum, because if capacity-wise, if you see some exceptions, kind of positive exception and then negative exception, all in all, the capacity is taken, like unusual capacity is not taken at all. So, but you could separately to analyze it, but I prefer to have kind of all together. So the idea is if their behavior of the object normal, I mean usual, no exceptions, and so this EV value would be just zero, nothing. It just indicates nothing unusual happens. So most of the time it's supposed to be zero. It's easy to analyze. But if something becomes unusual, this value could be positive or negative to show you the higher than usual the matrix value or less than usual. I already used this metric in other presentations about, because this matrix could be a very interesting indicator of starting some change, some event, starting new trend. So using this formula, just finding this situation when this EV changed the sign from positive to negative will give you some event which indicates new trend starting. It's interesting. Mathematically, you could discover some recent changes in the behavior, changes of patterns of the behavior. It's interesting way to detect trends. That's why it's not only exception detection but also trend detection using this technique. But even regardless of this usage for forecasting, just to plot this value, could you emphasize some findings? This is an example. I used BERT to build the control charts against this EV value, EV metric, and the formula is simple. It is integral by the nature, but actually it could be calculated just using some subtraction, actual data and control limits, and sum up them all together. And the formula is seen on this screen. That's maybe not very good, too busy, but it's pretty easy. And then I did the same manipulation just like for the control charting. The standard control charting, and you could see the result. Actually, I built two control charts together just to see how it could be used. I already mentioned their control charts against CPU utilization, like here, already shows that some exception happened kind of before the minor exceptions become kind of severe. But if you look at the EV control charts, it becomes absolutely clear. And even very small spikes, it's not zero spikes, it's a very early stage. It is a really early warnings. And you cannot miss it, because it was 0, 0, that suddenly something happened. But it reflects some early warnings, some change just become more and more severe. This EV control charts can be easily built using a spreadsheet. This slide shows how it's calculated. So it's really easy. Again, you see this early warnings here. It was 0, 0, 0, and suddenly something. But even small something has serious meaning in this case. If this situation were implemented, there are further exceptions like these severe exceptions could be prevented. And the last thing is how to detect exceptions, how to create a smart alerts based on this concept. Again, the alert should be done when exception happened, when the real data, actual data exceeds upper or lower limits. Yeah, you need to work out on how to capture it. But it could be done also by using the SQL scripting, and this is example. It's a DB2 type of SQL scripting. It's just it's not real DB2 script. Just to show how it could be done. I just simplify it a little bit. But again, you could see here the same concept. You need to have a baseline and some temporary table, then the actual metrics, and then combinations, the join two. And plus, you need to create some criteria. The criteria, in this case, criteria is very simple. I decided to apply simples rule when their upper limit and low limit are the same. 0 standard deviations. So the average actually is it's a little more than average. It's kind of unusual. Yeah, it doesn't make sense to analyze everything, but you know, it's a good filtering criteria. And then you can just take a look at the top 20 objects which had this exception value, and it will give you the top 20 situation which needs your attention. So it's a simplest way to build this detector. But of course, you could use a more complicated thing to use not just a 0 standard deviation approach, but also just some percentiles, etc. But it's going to be a little bit more complex script. But I like one-page scripts. I love it. That's why I just enjoy these examples. They are really small. So that's it. Actually, if everything is ready to build a SEDS-Lite, just using open source tools. There are more complex version. And actually, I even have one posting about how that could be done using Cognos. Yeah, if you have the Cognos, for instance, you could use similar things like a blur. So please take a look at my blog, and there my blog link in my cards here you could pick up, and also it is on this screen you could see on my presentation. I'm going to keep publishing some hints. The blog called System Management by Exception. It's the blog devoted especially for this SEDS type of methodology. Please.